Okay, so we've covered getting started. We've covered how we might manipulate observables using these things called operators and playing with time. Now, what we've done so far has been a little bit contrived, and we want to bridge this gap between the real world and the reactive world. How do we take things that are written in a different style, not in this reactive style, and expose them to us so that we can use them? So what I'm going to do is show us how we can create our own observable. Now, you might imagine why creating an observable is useful. As I was talking about a user clicking on buttons to create a stream of events. We would want to know how to turn a traditional event listener into an observable, for example, and various things like that. The first observable I'm going to create is a stream of Fibonacci numbers that runs for forever, and we're going to use that we're going to leverage that to make our Fibonacci application. So what I'm going to do is I'm going to make a new file, and I'm going to call it RxFibonacci. And the role of this file will be to create our stream of Fibonacci numbers. So first thing I'm going to do is I'm going to import io.reactivex.star, and then I'm going to make a class. It's going to be called RxFibonacci. Now in it, I'm just going to have a one static method which returns an observable of integers. I'm going to call it fibs. It's going to give us our Fibonacci numbers. Now, to do this, we use a method called observable.create. And it gives us a subscriber. Let's take a little more detailed look at that function. So observable create works like so. You pass it a lambda which takes in a subscriber, you do some work, and every time you want the observable to emit something, you just call subscriber.onNext. You'll recall that when we initially used observables, we used this .subscribe function to subscribe to it, and we implicitly gave it a subscriber. And that goes upstream, and that eventually becomes this thing, and then you call .onNext, and that's when that function that you wrote, that system.println function, gets called. Basically here with this piece of information that we pass to it, with operators in between, of course. So what we want to do is we want to do the stock standard bit of code for writing a Fibonacci series. So just to clarify, Fibonacci series is when the next number is the sum of the two numbers before it. So let's say this first number is 0, the second is 1, 0 plus 1 is 1, so the third is 1, the fourth is 1 plus 1 is 2, etc., etc. So we're going to write some nice imperative mutable code to quickly, I won't delve too much into details. So we have a previous number, a current number, we have an infinite loop, and then we say int all prev equals prev, and then we say int prev equals current. Don't want to put it in there. And then current plus equals old prev.
Although you should get current equal the one in the beginning, otherwise.
Thank you. That would have been tragic, wouldn't it? So now we want to plug in all the Rx stuff. So we want to call subscriber.onNext of 0, subscriber.onNext of 1 in the beginning, just to get those two initial numbers out the door. And then here we want to call subscriber.onNext of current. Now you don't need to be particularly attentive to see that this is an infinite loop here, and this is going to lead to all kinds of trouble. I won't waste your time running it. So what we want to know is when do we not want to send infinite Fibonacci numbers down the pipe anymore? And we can basically change this to a not subscriber dot is disposed. So this basically says, while the subscriber is still asking for stuff, give it stuff. But whenever something happens downstream, so for example, an observable, the subscription completes, it finishes, then stop sending stuff. And we'll see the conditions that we can run into for it to not send things. The next thing that we're going to do is we're going to take this stream of fibs. If you want to see this bit of code again, just let me know, and I'll flick back to it. We're going to take this stream of fibs, and we're going to use our concat map to turn our random numbers into Fibonacci numbers. So what we're going to do is we're going to map each random number to a stream of Fibonacci numbers, pick the element that we're interested in, dispose of the observable, and then pipe that through to our ultimate subscription. So the way we do that is we take our fake user input, we'll pipe it through a concat map, and then we'll get, say, x, and then we can call RxFibonacci.fibs, and then there's this nifty operator called element at, and then we can give it x. Now, something tells me that this isn't going to work. Yes. So my editor isn't giving me the error, but truth be told, element.at x returns what's called a maybe in RxJava. Now, a maybe encodes an observable that has either emitted nothing or one thing and completed, or errored, but we're not covering error handling. So concat map takes an observable, element at emits a maybe, and RxJava has been architected in such a way that there aren't really type hierarchies, and that's by design. But there's an operator called concat map maybe that fixes that and gets us around that problem. So now if I run this, I still get problems. Right, so what flatmap does instead of concat map is it allows the interweaving of observables. So in concat map, we had to wait for the previous emission to complete before starting the next one, but with flatmap, the next one is allowed to start before the previous one does. So if we check out the flatmap diagram, we'll see that this green one starts and this blue one starts, and then the blue and the green results are intertwined before they finally complete. And in the case of the Fibonacci's, that doesn't matter. We'd be able to, if there was a case where the maybes did matter, we'd be able to convert the maybe to an observable, and we wouldn't have a problem. Okay. There we go. So now we're getting a bunch of Fibonacci's spat out at us. Can anybody confirm whether these are Fibonacci numbers or not?
I think 34 is the one.
Great. I think we've made success. So we've had our fake user input generate some Fibonacci numbers, and of course this flatmap maybe, while putting Fibonacci numbers in a stream is a little bit contrived, and you can imagine that it was easy just to create a function that returns a particular Fibonacci number. But say for example, this is going to do the, oh no, it didn't do it this time. So say for example, we wanted to return all the first n Fibonacci numbers instead of just one, and then of course we could make a function that returns a list. But say we had some other kind of stream of things. Say we had a stream of news articles, and we wanted to pick a particular one from that stream, and element at would allow you to do that. Or you could take the first three elements if you're trying to create some sort of search feed, and you only want to turn the first three results that match your search, and then discard everything else. And you can use this construct for a whole bunch of other different things. Okay, so who has reactive Fibonacci numbers in front of them? Nice. All right, so the next thing we're going to do is actually turn our fake user input into real user input. And we're going to do that by making another Rx class. I'm going to create a new file called RxReader. And what this will do is it will give us input from the it'll give us console lines as the user types in a number and presses enter as a reactive stream. So I'm going to import io.reactive x.star again. I'm also going to import java.io.star to get all of the Java IO stuff. So I'm going to make my class RxReader, and I'm going to make a function called lines. It's going to say, so it's going to be an observable of string. It's going to be lines, and it's going to accept a parameter, which is going to be the thing from our console, the imperative version of our console, which is a buffered reader called reader. And what we want to do is make this into the reactive world. So I'm going to call it, I'm going to return observable.create again, and then I'm going to get an instance of a subscriber, and then I'm going to do what you'd usually do with a reader, which is to create a string line, and then I'm going to say while line equals reader dot readLine doesn't equal null. So this is while there are lines to be read in case the console closes. Then we call subscriber dot on next line, and I'm just going to do a little check to see if the subscriber is disposed after I do that, and then I'm going to break out of here. Finally, I'm going to call subscriber dot on complete to say if it is the case that the thing closes, we actually want to be correct and say that the observable also finishes. I'm pretty sure this is the case, but I think that observable.create is a safe operator and it properly synchronizes everything. So say that the observable is disposed, but you send an on next or an on complete to it, nobody's going to complain. It'll just throw those responses away. Or if you call on complete multiple times, or if you call on error and then an on complete, it'll figure it out, which is nice that you as the programmer don't have to worry about all those little bits and pieces. Now, there's something a little bit shady about this. Can anybody figure out why? Yes.
Not closing the buffer reader?
No, we're not, but that's not what I'm alluding to. We might want to be correct and close the buffered reader as well. Yes?
Exception handling.
Again, no. Errors will just, if this throws an error, the error will just propagate up the observable. Okay, so the thing was, with the Fibonacci numbers, we had this while loop, and that was okay because we didn't really want to do anything at the same time. But in true asynchronous code, we want to do things at the same time. But the problem is, while we're trying to do other bits of computation, we'll be sitting here blocked, waiting to read this next line. So by default, RxJava will just run everything on the same thread until you tell it otherwise. And it gives you some operators to actually turn that around. So the operators look something like this. This is a bit of a complicated marble diagram from the RxJava website, but the way it works is you've got an observe on and a subscribe on operator. And you give it what's called a scheduler, and that tells it what thread you want these bits and pieces to run on. So the observe on operator says any operators after this, run these on this particular scheduler, aka this particular thread. The subscribe on operator says run, this kind of not very well named, but the subscribe on operator says run the bit that generates your observable on this particular scheduler. So by that I mean this code here. So if you say .subscribe on on a particular thread or whatever, it will run your code, this particular piece of code on a different thread. So to leverage that, I'm going to import io.reactivex.schedulers. And they make this really easy, so I can just call .subscribe on and then schedulers.io. And now this is running a different thread, which is great. Now this will work, but now we've got the potential of different bits and pieces, different observables, causing things to run on different threads because we've got, for example, this timer, and now we've got this, and if we had multiple subscriptions going on, we might have some collisions of critical paths, etc., etc. So what we want to do, the safe thing to do, is basically use this observable operator on our, right before our doing our computation. We're going to say dot observe on. I'm going to copy this import from there. Check that in there. Dot observe on, and we're going to say schedulers dot trampoline, which is another oddly named scheduler, an oddly named RxJava thing. But basically, this will say from here on, we're going to run these. We're just giving it a thread to run it on. There are a bunch of different schedules that we can run. For example, there's computation, computation IO. If you're in Rx Android, you get a handle on the main thread for Android, which is an important concept if you're doing Android development. All sorts of things like that. But we're using trampoline in this case. It's important to note for things like IO, it's not like there's one IO thread that everything runs on. They will create a new one. So you can have all sorts of stuff going on. Yes?
If we're running this on a different thread, won't it affect the blocking subscribe?
So the blocking subscribe is not being run on a different thread.
Okay.
So that's still in here on this main function on our main thread. So RxJava has scheduling magic that makes sure all the threads coordinate and talk to each other. And when you call something like blocking subscribe, it will block correctly. And we can demonstrate this. I might. Hopefully, I don't have to eat my words. Well, so I want to exchange this fake user input for some real user input. So let's hook this up. So we've got RxReader, and it takes in a buffered reader. I'm just going to make a quick utility function that gives us those lines. So we've just got to throw in some standard Java stuff. So we're going to make a new buffered reader. We're going to make a new input stream reader, and we're going to take that from system.in. So that's going to create our lines from input. Finally, we need to make a quick change to our build.gradle file if you're using this Gradle run command. For people using other IDEs like Eclipse, I'm not sure what exactly you're going to have to do to make this work, or if it's even going to be a problem in the first place. But in my build.gradle, I have to write system input equals system.in. I believe that is the magic incantation that I have to write. Okay, dokie. Could not send property system input. Standard input. Okay, now we've got some. Okay, so the type system has gotten a bit upset at us as a result of me putting this .subscribe on, so the inference hasn't quite been able to work it out. To fix that, I'm just going to put string in here, and then everything is going to be just fine. Okay, well those are still my random ones. Now I can change you for a RxReader dot lines from input. I probably called it the wrong method. Oh, the next thing I need to do is use our operator map to convert the strings to numbers. So, so I'm going to change the line to integer.parseInt line. It doesn't matter. As long as observe on is somewhere before our subscribe, it doesn't really matter. Errors after errors. And these need to be static. Okay, moment of truth. Here we go. Now you'll see that it seems kind of slow. That's not an RxJava thing, that's a Gradle thing. It is taking some time to get the console input to our application. But now we have a reactive stream of our input that is working. So to reiterate on what we want to do to make that happen, wow. As I said, experimental software. What I want to do is make a reactive console reader using this observable.create. Don't forget to import all your Java IO stuff. And then we want to use observe on and subscribe on to fix all of our thread safety. Now something to explore is possibly trying to do some number crunching that would warrant running on another thread that would actually be quite blocking. For example, calculating very large factorials or prime numbers. Creating a stream of those could be an interesting challenge. But we can imagine actual use cases, for example, making blocking network requests, reading files. These are all things that we want to do asynchronously in a UI. And these are the tools that we have at our disposal to do this. A lot of the time, you can just use a drop-in library. Those exist. So, for example, there exist HTTP libraries that give you observables to represent HTTP requests instead of blocking, for example. And those you don't want to be diving too deep into this low-level code as much as possible. So those are all the things I had planned for today. But does somebody want to throw a question at me about? Okay, this question might be good. What is it? What's up? Observe on, yeah.
Observe on together. Yes.
Yeah. So the question was, why would you want to use .subscribe on and .observe on? Why are they necessary?
Why both are necessary at the same time?
Yeah. So the short answer is that both of them aren't strictly necessary. It's mainly subscribe on that you want. So subscribe on allows you to make sure that this bit of code runs in a separate thread, so it doesn't block the rest of your execution. But that means that all of the stuff that it invokes is also going to be running on that thread. So it might be running asynchronously compared to another thing. Now, if we only have one subscription, so that doesn't really matter. But say we had multiple subscriptions. Say we had another bit of RxReader or whatever somewhere else, and maybe not RxReader, but maybe something else observable, and it was running on a different thread with a completely different idea of what time it is and all that, and say both subscriptions modified some bit of shared memory, some kind of critical path, and that's not strictly thread safe. And those two could be intertwined, and they could basically conflict, and that is bad. So what using observe on, especially in respect to subscribers.trampoline, it makes sure that these jobs all get run on the same thread. They all get run on this so-called trampoline thread, and so that means they can't hit the critical path at the same time. It's not necessary in this case. I can show you. It works. It works just fine. But yeah, so this is more for correctness than for the actual practicality of this. Is anybody interested about how you might model a particular idea in RxJava? Does anybody have any questions about what are some things that you'd want to do in an application that you thought would be complicated? And I can possibly demonstrate how we can make it easier. That's a good question. So the question was about if you've got lots of user elements or interface elements, lots of different things that can be clicked on, how might you want to model that? Do you want one observable? Do you want multiple observables? And the short answer is that it really depends on your architecture and your style. So these things are intended to be lightweight and performant, so it wouldn't be an issue if you made an observable every time you wanted to listen for something to be clicked on. That's fine. There's no problem with that. It adds very little overhead compared to the constructs that the language would offer, for example, an event listener anyway. But you could equally create, so for example, in JavaScript, there's this concept of event bubbling. If you have a hierarchy of elements and you have a button, and a click event will eventually bubble up to the overall HTML container. If you do a listening for click elements, on that HTML container, you have one observable stream of every click in your entire application, and then you just filter out the ones that you don't want. And then you have one global observable that you can use for everything. And either approach works. And yeah, it depends on your personal preference, really.
Right, but it is like it's something that you might do instead of an unchanged or an event listener.
Yeah. And hopefully you have a library that will make it really easy for you to be. So for example, in RxJS, there is a you call observable.from event. You give it an element, you give it the name of the event, and it will turn it into an observable for that event. Right. And so you create those utilities that make the conversion between these two worlds very, very easy.
It just seems like eventually what that boils down to is basically a callback, or like is basically a function that's going to run.
Because there's this blocking subscribe thing here, right? And that you pass in a callback, and so we're still not fixing it. But the fact is that, say that event listener was a utility library buried deep somewhere, and instead, so every single time you wanted to leverage that or expose that event listener in some way, the function that was calling that utility library would then have to accept a callback argument, and then the function outside of that would have to accept a callback argument as well, etc. When you're doing function composition, callbacks become nightmarishly difficult. And so having them as values means you can just return this one observable thing up. As well as that, if something accepts an observable for event listeners, that makes testing really easy. So say you want to test some component that's saying when something is clicked, do this thing. Instead of having to do some scary state management, you could just inject an observable that is mimicking, like we've done this, mimicking some fake user clicks as opposed to the real clicks.
Right.
And the other advantage, the primary advantage of RxJava is the wealth of these operators, and there are so many different operators to encompass basically every kind of asynchronous computation that you want to do. And writing your own operators is also really easy. Cool. Okay, guys. Well, that's all I had planned for today. Thank you so much for coming. So sorry for that things were a little bit disorganized today, but I hope you felt it was worthwhile. Thank you.